polar curves, let x is r cosine theta, y is r sine theta. That is something that we know that makes a connection between rectangular and polar curves. In the previous problem, we found dx over d theta, dy over d theta. So we'll get to that in just a second. Going back a long time ago, which is last week, when we did length of a geometric curve. What was that length? You know that sorry, you have an answer.
The integral of square root of dy over d theta squared plus 1. Or did you take this constant?
So she actually is giving the final answer, but based on what we did last week, do we remember? If you have a function, in other words, it passes the vertical line test, we can find the length of that curve using integrals. So the integral part is right, square root part is right, the 1 plus part is right. The only place you made a mistake is when you threw that theta in. Do we not remember? Do you have it in your notes? I forget your name.
I see. Oh, yeah, I have to read it. It's square root of dx over dt squared plus dy over dt squared.
Remember that entire derivation that I did with Pythagorean theorem, how it relates to the distance formula, how we use that distance formula, put it with integrals to get the length of a function between 2 points. Same logic. We know the length of a curve from parametric equations, square root of dx over dt squared dy over dt squared times dt between 2 points. I'll just call it A and B, right? That derivation came from 1 plus dy over dx squared. That came from the Pythagorean theorem, which came from a simple right angle triangle. In that formula, if we replace t by, any thoughts? Theta. We have a formula, but the issue here is you would get a giant expression sometimes because the previous problem, for instance, we had a pretty lengthy expression here, pretty lengthy expression there, and you would end up getting a huge expression or lengthy expression inside the integral. And do keep in mind, there are cases where you can only set up the integral, but you won't be able to integrate it. So it will happen. You'd have to use a calculator because it's a definite integral. We know dx over d theta from the previous problem. We use product rule, take the derivative of that. So length would equal to 2 points A to B dx over d theta, which is negative r sine theta plus cosine theta times dr over d theta. Good. plus dy over d theta, you would have r cosine theta plus sine theta times dr over d theta. Erase the rest. I'm going to put the square in a second, so square times d theta. A to B, you can distribute FOIL, whatever. A plus B squared is A squared, which is r squared sine squared theta, plus B squared cosine squared theta times dr over d theta squared. Longest group. A squared, B squared, 2AB. So minus 2r sine theta cosine theta times dr d theta. Once again, a plus b squared, you'll have a squared, so r squared cosine squared theta, b squared sine squared theta, dr over d theta squared, plus 2r sine theta cosine theta dr d theta. Good. All I'm doing is a plus b squared here, a plus b squared there. Good. The polar curve, the length changes with respect to the angle, so the integral is with respect to theta. So you have d theta outside. Okay, those two will go away. Yes. R squared sine squared theta plus r squared cosine squared theta would equal to, any thoughts? R squared. Very good. R squared plus cosine squared, and call this, you know, A. Cosine squared theta times A squared, sine squared theta times A squared will give you cosine squared theta times A squared, sine squared theta times A squared, A squared. So A squared, but A is nothing but dr over d theta squared. And that is the formula length. Well, we derived oh, not bad. Let's say the radius of this circle is 4. And hopefully I don't mess this up. Oh, still not bad. Kind of bad. 0, 4. And I want to know the length from here up to there. Good. Do we know that length? What was the question? What is the length of that part right there?
It'd be pi over 2.
Huh?
It'd be pi over 2.
Pi over 2. What is the total length? Total length? No, just give me the answer if you have it. 2 pi? Answer is 2 pi. The total circumference is 2 pi r. Yes? 2 pi times 4 is 8 pi. What? Pi over 2. 8 pi divided by 4 is 2 pi. So 2 pi here, 2 pi there, 2 pi, 2 pi. Good. I think you just divided it backwards. So 2 pi, we know the answer. Well, I can get it from here as well. I'm going from here to there, so I'm changing the angle. So starting at 0, where am I ending? What? Pi over 4. Yeah, pi over 2. Pi over 2. 0 to pi over 2 square root 4 squared plus what is dr over d theta? There is no need to derive or even try again if you understand the concept. From last time, the circle, we are trying to find dr over d theta. It is the rate of change or instantaneous rate of change of the radius with respect to theta. Ask yourself, does the radius of the circle change as you change the angle? No, stays the same. No change whatsoever, 0 squared. And if you insist on doing the derivative, well, what is the derivative of 4 with respect to theta? 0. So 4 squared root you can pull the 4 out, so 4 integral 0 to pi over 2 d theta. Full integral of d theta is simply theta, so 0 to pi over 2, so 4 times pi over 2, which is 2 pi. Same answer. Good. Now you may wonder, well, why do we bother? We know the answer right here. Let's say if you want to find that. Sure, in geometry we have arc length and all that stuff. You can use that to find that length. But what if you have a weird curve and you want to find the length? That way. I'm going to write a separate problem, but let's just. Okay, something like that. What does that remind you?
Looks like a stain.
A stain?
Spot.
Okay. Ah, I could see it. Had I gotten rid of that, I could have come up with the starfish. It's okay. Too late. Regardless, if you want to look at the length from here to there, would you be able to come up with that length? from that point all the way up to that area. No, but if I tell you polar equation for that curve, would you be able to come up with the length? Yes. So here is an example.